Have you ever wondered how facial recognition works on social media? Or how object detection helps in building self driving cars? It is all possible thanks to Convolution Neural Networks CNN. Hello everyone, I am Mayank and welcome to Simplilearn. Today we will take you through a hands off lab demo of how we can use CNN model for image classification in machine learning. For amazing videos like this, subscribe to our YouTube channel and press that bell icon to stay updated. In today's session, we will discuss what CNN model is, and moving ahead, we will discuss how does CNN recognize images. After that, we will see layers in CNN. At the end, we will do a hands-off layer demo of image classification using CNN. Before we move on to the programming part, let's discuss what CNN is and proceed further for the same. What is CNN? A convolutional neural network is a feed-forward neural network that is generally used to analyze visual images by processing data with grid-like topology. It is also known as ConvNet. A convolutional neural network is used to detect and classify objects in an image. So this is a neural network that identifies two types of flowers, orchid and rose. In CNN, every image is represented in the form of an array or pixel. Here you can see it is a real image of digit 8 and it is represented in the form of an array, and here 0 represent negative values and 1 represent positive values. Okay, it's creating 8 here. So digit 8 represent in the form of pixels of zeros and ones. So now let's understand the convolution you're operating using two matrices A and B of one dimension. Now let's understand the convolution operations using two matrices A and B of one dimension. A equals to 532, 597, B equals to 123. So in convolutional operation, the arrays are multiplied element wise and the product is summed to the create a new array which represent A into B. So here A into B 532 and 123. Multiply the arrays element wise and this is the sum of the product. So the first three elements of the matrix A are multiplied with the elements of matrix B and the product is summed to get the result. So A into B is 17. The next three elements from the matrix A are multiplied by the element in the matrix B and the product is summed up. So here sum of the product is 22. So A into B is 17 and 22. This process continues until the convolution operation is complete. So moving forward, now let's discuss how does CNN recognize images. So consider following these images. The boxes that are colored represent a pixel value of 1 and 0 if not colored. When you press backslash, the below image gets processed. And when you press the forward slash, the below image is processed. Here is another example to depict how CNN recognizes an image. So consider this is a real image. Now it is represented in the forms of black and white pixels. And this image is represented in the form of matrix of number. Here you can see where here the black part and here is one value. So it's creating the image represented in the forms of matrix of numbers. So as you can see from this diagram, only those values are lit that have value of 1. Okay, this is how the CNN recognize the images. Now moving forward, let's see layers in convolutional neural network CNN. A convolution neural network has multiple hidden layers that help in extracting information from an image. The four important layers in CNN are: first is convolution layer, second is pooling layer, third is ReLU layer, and fourth is fully connected layer. So now let's start with convolution layer. So this is the first step in the process of extracting valuable features from an image. A convolution layer has several filters that perform the convolution operations. Every image is considered as a matrix of pixel value. So consider this the following 5 into 5 image whose pixel values are either 0 or 1. There is also a filter matrix with a dimension of 3 by 3. Slide the filter matrix over the image and compute the dot product to get the convolved feature matrix. And the second is ReLU layer. ReLU performs an element-wise operation and sets all the negative pixels to 0. It introduces non-linearity to the network and the generated output is a rectified feature map. So below is the graph of ReLU function. So the original image is scanned with a multiple convolution and ReLU layers for locating the features like this. ReLU layers creates the feature maps like this, and after that input feature map creates the rectified feature map. This is how black negative is to white non-negative values or positive values you can say. So it will create the rectified feature map, ReLU layers. So now third layer comes into the action, pooling layer. So pooling is a downsampling operation that reduces the dimensionality of the feature map. The rectified feature map now goes through a pooling layer to generate a pooled feature map. So this is a rectified feature map. So here 3, 4, 1, 2. From this it will take the maximum value. Here is 4 and from this it will take the maximum value 7, and from this it will take the 8 and 6. Okay, so max pooling with 2 by 2 filters, and this is the stride 2. The pooling layers uses various filters to identify different parts of images like edges, corners, body, feathers, eyes, and beak, as you can see from the picture. So now let's see how the structure of CNN looks so far. Here's the diagram represent the structure of CNN so far. So the next step is a process is called flattening. This is called the flattening process. So flattening is used to convert all the resultant two-dimensional array from pooled feature maps into a single long continuous linear vector. So as you can see, it is a pooled feature map. After flattening, it convert into single long continuous linear vector. The flattened matrix is fed as input to the fully connected layer to classify the images. So this is CNN, here comes the ReLU, then pooling, then it is the input to the final layer. After this, so input image, then convolution layer, then ReLU layers comes in, then pooling layer, then flattening. Now this is fully connected layer, which is CNN. This is how the CNN grade after connecting the three layers, ReLU, convolutional, and pooling layers. So this is how exactly does CNN recognize images. Okay, the pixel from the image are fed to the convolution layer that perform the convolution operations here. Then it results in a convol map. The convol map is applied to ReLU function here. The convol map applied to ReLU function to generate a rectified feature map. Here it creates the rectified feature map. And the image is processed with multiple convolution and ReLU layers for locating the features. Then different pooling layers with various filters are used to identify specific parts of the image. Here the max pooling does. So the pool features is flattened and fed to fully connected layers to get. This is the flattened fed to fully connected layers. This is fully connected layer, and that is how it got the final output bird. Okay, this is a feature extraction in multiple hidden layers classification in the output layer. So now moving forward, let's start the programming part. So here, so this is the Python kernel file. So here first we will change the name CNN for beginners. Okay. Rename. Okay. Yeah. So first we will import some major libraries of Python. So I will write import numpy as np. Then I will write import pandas as pd. And import matplotlib dot pyplot as plt. Import cborn as sns. Then import keras. After that import tensorflow dot keras. So NumPy is a Python library used for working with arrays. It also has a function for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. And the second one is Pandas. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operations for manipulating numerical tables and time series. And the third one is Matplotlib. So for Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it represents a strong open source substitute for MATLAB, and the API application programming interfaces for Matplotlib allows programmers to incorporate graphs into GUI applications. And the fourth one is Seaborn. Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. For a brief introduction to ideas behind the library, you can read the introductory notes for the paper. And the Keras. Keras is an open source software library that provides a Python interface for artificial neural network. Keras acts as interface for the TensorFlow library up until version 2.3. Keras supported multiple backends including TensorFlow, Microsoft Cognitive Toolkit, Theano, and PlayML. And the fourth one is TensorFlow. TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks but has a particular focus on training and inference of deep neural network. Okay, so here we are going to load data. First, let me write the line x train, comma y train, comma x test, comma y test equals to krs dot datasets dot fashion MNIST dot load data. Okay. So there are 10 different classes of image as following, like t-shirt, top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, ankle boot. And the image that I mentioned are 28 by 28. So in this, we are splitting the data into training and testing set. So what is MNIST? So fashion MNIST consists of 60,000 training images and 10,000 testing images. It is MNIST like fashion product database. The developers believe MNIST has been overused, so they create this as a direct replacement for the dataset. Each image is in grayscale and associated with a label from 10 classes. Each image is 28 pixel in height and 28 pixel in width for a total of 784 pixels in total. So each pixel has a single pixel value associated with it, indicating the lightning or darkness of that pixel. With higher number, meaning darker, the pixel value is an integer between 0 and 255. So moving forward, we will see that how much data we have in training and the testing. So here I will write x train dot shape. There is no need, I guess, for this, comma y train dot shape. Okay. See, we have 60,000 rows and 28 columns for a particular data set. Okay. Now x test dot shape, comma y test dot shape. Here are in the testing we have 10,000 rows and 28 columns. I already told you before when I talked about the dataset, like we have 60,000 training images and that 10,000 testing images. Okay. So, and if you want this full code, I will provide you in the description box below. Just comment for the same that you want the full code. Okay. So now let's train the data. Okay. Then X train the label Y underscore train. Let's see this. Fine. So what I will do with better visuals, I will do like this. Huh. So now let's see for the show images. So here I will set the class labels. Class labels t-shirt, t-shirt, or it can be top. Okay. Then trousers and pullover. Then dress. Then coat. then random dot sneakers, then bag, ankle boot. So let's see some images. So what here? I will write class. No, no, no. I will write plt dot show xtrain, comma cmap. So great. So see, it is ankle boot. It's look like an ankle boot. Let's see one more. Okay, plt dot I am show strain cmap equals to grace. Okay, it is a t-shirt. We have 60,000 images in the training set, so we can check the any. Let's see one more. plt dot I am show strain 15 equals to grace. Okay, there's a shoe. Okay, let's copy it. The last we are checking for the 50. Something dress. Okay, so this is that for the training. That is why we are writing here X train. Right. So now let's see the all the categories. Okay, like sneaker, ankle boot, coat, and t-shirt. Okay, sandal and all. So for that, I will write here plt dot figure figure size. I will give 16 by 16. J equals to 1 for I in np dot random dot rand int 0 comma 10,000, sorry, 1,000 only, 25. ELT dot subplot 5 comma 5 comma j plus equals to 1. ELT dot I am sure xtrain I cmap equals to what? Grace. Okay. Then plt dot axis of and plt dot title again calibrated. What I will write here dot format as equals white rain comma white rain. Okay, so now let's see, run it. Okay, so there is an error. Object has no property cap. Okay, it is C map. See, now you can see the sneaker, bag, pullover, sandal, dress. So all the categories. Okay, shirt, coat, bag, sneaker. This is for the training. The trousers we are training all the images. Okay, for the model. So now what we will do, we will reshape some training data. Okay, the length and the testing data length. Okay, so moving forward, we will do that. Let's do the reshaping and all. So fashion m equals to krs dot datasets dot fashion right here x train y train comma x test equals to fashion data x train this dimensions. So here I will write x train minus 1. Okay, or we can write x train equals to x train dot reshape length x train. Okay, here I will write x test equals to np dot expand dimensions x test comma minus 1. Okay, here I will write a1 equals to np dot array d dot unique train 1 equals to and here I will write for
A1, then E index 1 dot append to list y train dot index I. Okay. Then print index 1. Okay. So cross check for I in index, print y train I. Okay. So here I will write plt dot figure size was to 24 comma 24. Okay. For x comma y in enumerate index 1 is this. Here I will write print x train dot shape, then plt dot subplot 2 comma 5 comma x plus 1 plt dot I am show TensorFlow quiz and x train y equals to grace. Okay. plt dot title dot format a1 x. Okay. X train and p dot index expand times x train minus 1. Okay. So there is a okay. Valid index. What I wrote here, let me check. Import numpy as np. The error. Okay, let me check the error. Working. These are the 10 category. Okay. These are the pixel size 28 into 28. Okay. So moving forward, what we will do, we will change the dimensions. Okay. And then after that, we will do the feature scaling. Okay. For the changing dimension, we'll do x train dot ndim. 3 means three-dimension image. This one is the three-dimension image. Then x train dot shape. Okay, 60,000. Then what I will do? X train equals to np dot expand train comma -1. Test equals to np dot expand test comma -1. So four-dimension image x train m. Okay, and dim. This is a four-dimension image. Okay, the next train dot shape. Okay, fine. So now what we will do the feature scaling. So for the feature scaling, I will write here x train equals to x train by 255. Okay, so here I will write x test equals to x test by 50. So what is feature scaling? Feature scaling is a method used to normalize the range of independent variables or features of the data. So in data processing, it is also known as the data normalization and is generally performed during the data pre-processing steps. Okay, so let's see the data is in 0 to 1. For that, I will write here small code x train in 0. So now what we will do, we will split the data set for the validation set. Okay, for that we will write here from sklearn dot model model selection import train trust it train x value comma y train y value equals to train test It. And here I will write interest split, then okay, split, then I will write here x train, comma, y train, comma, test. Over here, now I will write x train dot shape, y train shape 8000. Okay, then x value dot shape, comma, y value dot shape. Okay, 12,000. See, our total images in X train were 60,000. So now we did the train test split. Okay, so test size is 0.2. So we split into like 80 and 20. Okay, so that is why there are 48,000 images. So now we'll make CNN model. Okay, convolutional neural network. So for the convolutional front end, we can start with the like three convolution layer with a small filter size and modest number of filters. Okay, followed by a max pooling layer. The filter maps can be the flattened to provide features to the classifier. Okay, so we know that we required an output layer with like 10 nodes in order to predict the probability distribution of an image belonging to each of the 10 classes. This is also require use of sort max activation function between the feature extractor and the output layer. We can add a dense layer to interpret the feature, in this case with the 128 nodes. Okay, so listen that like all layers will use the ReLU activation function and the weight initialization scheme, like both best practices. What we will do, we will create model. Okay, so this is the code for the model. Okay, so in this we use the layers. These are the three layers: layer 1, layer 2, layer 3. Okay, so as I said to you, we will start from the max pooling layer. Okay, so here we used units equals to 128 and activation equals to ReLU. Okay, and there is dense again the layer. So max pooling, here is a term max pooling 2D. So it is a pooling or max pooling operation which calculates the largest or the maximum value in every patch and in the every features. Okay, so it is used in the pooling operation that calculates the maximum value for the patches and to create the pooled feature map. Got it? And here is a dense. So dense is like in any neural network, a dense layer is a layer that is deeply connected with the preceding layer. So which means the neurons of the layer are connected to every neuron of its preceding layer. The layer is mostly commonly used in artificial neural network. Okay, and there is dropouts, like how much it will be dropout for every, layers. From every layers there is one more word, flatten. So flattening is used to convert all the resultant two-dimensional array from pool feature map into a single long continuous linear vector. The flattened matrix is fed as input to the fully connected layer to the classify image. Okay, and this softmax is a like equation or a function you use to activation function in the output layer of the neural network, and that predict a multinomiality probability distribution. That is, softmax is used as the activation function. Okay, and ReLU is again, you know, uh, a particular layer forward the visuals. So now what we will do, we will plot the neural network for the workflow. Okay, keras dot details plot model model to file question model dot png. It's happening. Show tips question true. Here I will write show layer question true. There is an error. Okay, model is not defined. So what we have to do, we have to install here py. Okay, pip install py and install graphviz. Okay, so let me install and let I will come back to you. So here what I will write, we'll see the model dot summary. This is the model summary. Okay, and now what we will do, we will compile and model fitting, do the model fitting. So here I will do the model dot compile optimizer equals to Adam equals to categorical cross tropy. Okay, here I will add matrix equals to accuracy. Okay, so now I will write model dot fit. Okay, will write here. Let me delete this. Model dot fit train, comma train, comma epochs equals to 20, comma batch size equals to 512, comma verbose equals to 1, comma validation data equals to x var, comma y. Okay. So it will take time. It will run till 94. Okay. The loss, the accuracy will come. So we have to wait for some more minutes till let it be complete. It will go till 20. So I will get back to you when it will be complete. Almost 14 done. 15, 16, 17, 18, 19, 20 are left. So we'll wait and we'll see. So an epoch is when all the training data is used at once and is defined as the total number of iteration of all the training data in one cycle for the training and machine learning model. So another way to define an epoch is the number of passes a training dataset takes around an algorithms. Okay, we'll wait till 20. Seventeen. Three more left. They are the loss, accuracy, and validation loss, value loss. If you want this full code, you can comment. And if you have any query related to Python, machine learning, or anything, okay, you can comment down. Our team will reach you as soon as possible. So two more, 19 and 20. Accuracy, our model accuracy is good, 93. If you have any query, you can comment down below. Okay, 19 is done. Final 20 is going on. Epoch. You can enroll in our course of AI and ML. You can check the link in the description box below. In course. After this, we will test the model, then we will do evaluation, then confusion metrics, and then visualization of the output, the final output. Okay, yeah, so it's done. So now let's test the model, testing of the model. So now let's start the testing the model. Okay, so here I will write model dot predict p dot expand okay, x test at 0 axis round. Okay. Round is how many decimal points. Okay. So now np dot argmax and model dot predict np dot expand aims x test. This will be 0. This will be 0 dot round added 2. Okay. Okay. Axis not okay. So here I have to write x equals to 0. Okay. So now cross check y test 0 same. Okay. Then y prediction equals to model dot predict and x test to prediction. So now we will evaluate. So model dot evaluate dot evaluate test comma y test. Okay, so now let's do the model evaluation. So accuracy given by train set is 0.94, which is very good, 94%, and accuracy given by test set is 90%. So thus we can say that our model is generalized, so no overlifting or not underfitting. Okay, so now confusion metrics. So from sklearn dot metrics import confusion metrics. Okay, then plt dot figure, then figure size equals to 16 comma 9 y underscore prediction y prediction equals to np dot arg max label or label in y prediction. Then cm confusion matrix equals to confusion matrix y test y prediction labels. Okay, so now we will write, we'll create heat map sns dot heat map confusion matrix comma a not was to true, then fmt equals to d comma x tick labels equals to class dot labels, then y tick label equals to class labels. Okay, there's an error. Yeah, see, the heat map is came. Okay, this for the t-shirt, pullover, dress, coat, and hair also. Okay, so now we will visualize the output. So plt dot, so it is like coming correct or not. Okay, expected and predicted. Okay, or you can say the actual and predicted. So plt dot figure figure size equals to 16 comma 30 equals to 1 for I in np dot random dot pendant comma 60 plt dot subplot x comma j. Then here I will write j plus 1 plus equals to 1. Then plt dot I am show x test I shape 28. It's 28 height and width. And cmap equals to grace. plt dot access of plt dot title here right actual equals to okay. Slash n predicted equals to dot format class labels y test test I p dot the max and y predicted is I. Then we'll write np dot arg max y predicted I. Press enter. Loading. So as you can see, actual is t-shirt shop, t-shirt and top. Then predicted is also fine. Okay, some error. Then trousers are same, sandals are same, ankle boot also same. So as you can see here, some are right and some are wrong. See, because the testing accuracy is 90%, the predicting accuracy is the training accuracy is 94%. That is why. Okay. So this is the CNN of image classification, how you can use. And if you have any queries related any code or you want this full code, you can ask me in the comment section. Okay, I will provide you the full code. So mostly the predicted and actual are coming. Till then everything is coming good. So I hope you guys understand till here. If you have any question or any query regarding any code, or question, just put as in comments. Our team will shortly provide you the correct solution. So I hope you guys have much understood the concept of CNN. What is CNN? What is how CNN recognize images and that thing. So thank you so much for being here. If you enjoyed this video, please do subscribe to our YouTube channel and give a like to this video. Till then, thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.